All right. So I guess we'll start now, and I just want to thank everyone for coming, and big thanks to Elizabeth for setting this up for all of us. So a couple notes. I'm going to be taking questions, but so you can submit questions anytime during the presentation. However, I'm going to wait till the end to answer them. So I may not get to all of them, and the ones I don't get to, if you still have the question after the presentation, you can feel free to message me on Slack, and that's my Slack ID is right here. So today, I'm going to be talking about functional programming generally, and more specifically, functional abstractions, which is kind of one subtopic in the world of functional programming. And so some key principles that one should keep in mind, and some of this is JavaScript related. However, functional programming is more of a programming paradigm, and the mental model can really be applied to languages other than JavaScript. However, JavaScript is my language of choice for demonstration and examples. So first of all, functions are first-class values, which means that they're treated exactly like other values, objects, arrays, primitives. You can pass them as arguments into other functions, which is a big deal for functional abstractions, but we'll see that a little later. So an interesting thing about functions, although they're first-class values like all other values, something that's special about them is that they store executable code. So if we store a function in a variable, that variable is ultimately a reference to actual code statements that have not been executed yet, but we can execute them at our own will just by using invocation syntax. And the two types of functions that we'll be talking about are first order and higher order. And I'm going to be referencing two time zones, and these are unofficial terms, but invocation time and author time. The difference between the two is that author time for functions is when you actually define the function, and invocation time is when you use invocation syntax to actually execute the stored code. All right, so a little more about functions is that, so like I said, functions are defined at author time, and we pass arguments into functions during invocation time. So invocation time always comes after author time. So you can't execute a function until it's first defined. And one pseudo exception is immediately invoked function expressions. However, the code still has to be stored prior to execution, so that gap is just a lot smaller. And if you haven't seen immediately invoked function expressions, just disregard that. And so functions package up behaviors in its function body during author time. So its behaviors are what's determined at author time. Then during invocation time, we pass in data input as arguments to the function, and then the stored behavior acts on unstored data. And so first order functions are what we typically think about if we try to imagine a simple example of a function. It's probably going to be a first order function that you're thinking of. So in first order functions, the set of behaviors in the function body are determined at author time only, and after author time and during invocation time, those behaviors cannot be changed. So this is a discussion of what the developer has control over when actually using the function and what they don't have control over. During invocation time, the developer has control over the data that's acted on by the function, but does not have control over any of the behaviors which the function packages up. And so I have some examples here in CoderPad, and so this also explains what author time and invocation time is. So this is a very simple function here. Perhaps not everyone is familiar with JavaScript, so this function is a keyword, and it tells JavaScript runtime that what's following it is a function definition. So this function's name is log, and it takes one argument, and phrase is a placeholder, a parameter for that argument. And then in the function body, which is defined by these brackets, is a behavior. And so the behavior, which in this case is a function call, a built-in function call, it acts on the argument passed in to our custom function here. So this is author time. And then during invocation time, I can use invocation syntax, which is just naming the function and putting opening and closing parentheses after it. And I can pass in data in the information, the behavior stored in the function body acts on that data. So if I run this, it should just log hello. And the big thing to realize here is that I can control at invocation time what's passed into the function for data. I can control what data the behavior acts on, but I can't change the behavior of the function once I've defined it, unless I go back, but then I'm back in author time. During invocation time, I can't change the behavior of the function. All right, so that's where higher order functions come in. So higher order functions enable the developer to control behavior at both author time, just like first order functions, and also at invocation time. So higher order functions store behavior just like first order functions, but the behavior that's stored in a higher order function can act on other behaviors as well as other data. And so I do have another example, so we'll hop back over to CoderPad. So I actually already explained this, so I'll just delete all that. So here I have an example of a function called repeater. And what repeater does, it takes 3 arguments. The first argument is expected to be an integer. The second argument is another function, and that's the special thing about higher order functions, is that they either take another function as an argument or return another function. And my examples are primarily of functions that take other functions. So it's taking stored executable code as behavior, and then it's going to do something with it. And then this third argument is aptly called arg, and what that's going to do is, well, we'll see right here. So this is a simple for loop, and all it does is executes as many times as the times argument value. And then what it does is it takes this third argument here and passes it into the function and executes it. So, and I can show that here, repeater 3 log hello. Oh, I guess I do need to keep log defined then. Sorry about that. So this should call the log function, which I defined above, which is a first order function, 3 times, and it should pass the string hello into log. So I'll just reset this. I pressed save instead of whoops. All right. So, and then I can change it, run again. And the great thing about this is that the higher order function repeater can take any function and repeatedly execute that function. It doesn't have to be the log function. And so during invocation time, that's what this is when I call it. During invocation time, it has the ability to add extra behaviors. So the log behavior, or I could pass in a function that adds, say, adds up all the numbers in an array. So that's an example of higher order functions. So, okay, I actually don't know why that border's there, but so functions can be thought of as abstractions. And I think the best way to think about this is through an example. So say we have to write a function that takes an array of numbers, and we need to find all even numbers in that array and return the new array. Well, that's the problem in plain English, and we can break that down a little better. So we have, in most problems, all problems, we have an input that we're dealing with, or set of inputs. And in this case, it's an array of numbers, and that maps directly onto a function's arguments. We also have an action, and the action is to find all the even numbers, or said another way, filter out all the odd numbers. That maps directly into the function body, or the code that the function body stores. And then the data output is also an array of numbers, or an array of even numbers, and that maps directly to the function's return value. So, and this is with first order functions that input, action, and output map directly onto the different parts of a function. And so an example of a first order function solution to this, we can see down here. So, like before, given an array of numbers, return an array of all even numbers. It's the input, an array of numbers. So we know that we're going to need that as an argument. The action is to filter out all odd numbers. So that's going to be what we're going to be doing in our function body. And then the output is an array of even numbers. So we know that at the end of our function body, we need to return the array of even numbers. So here in the function body, I initialize an empty array, and then I iterate through the array that's passed in as an argument, and I run a simple test right here. This is just a test for evenness. We don't have to go into how any of this works if you're not familiar with JavaScript, because we're really focusing on concepts here. And then all this does is pushes the even elements, even numbers, into the evens array, and then it returns it. So this is, once again, this is during author time. So during invocation time, if I log the return value of get evens, it should give us 246. So the thing about it is that I can't change this later in my code base. And so say I wanted to get all odds, I would have to write an entirely new function, because all of the behavior in this function body is hard-coded. So really this action is composed of two sub-actions. There's the filtering out, and then there's running some sort of test for whether a number is odd or not. And so with first order functions, all of that is hard-coded right into the function body, whereas in higher order functions, we can split that behavior up. And so just hop back to the presentation. So the first order solution that we just looked at depends on the data input always being an array of numbers, depends on the data output, expectation that it's always an array of numbers as well, and depends on the action being a filtration out of odd numbers. So like I said just barely, what if a requirement was added on to that same function? Now that same function needs to be able to somehow accomplish filtering out all even numbers and returning an array of odd numbers. And like we said, there's no way to do that with a first order function. So what's the solution? Well, once again, the solution is to write a higher order function instead. And there's a special way or a method to structure your higher order functions. So recall that the first order structure, everything maps one-to-one between the input, action, and output, and the different components of the function itself. So the input is an array of numbers that maps directly to the arguments. The action is to filter out odd numbers that maps directly to the body. And the output is the array of even numbers, which maps directly to the return value. So we can generalize these actions a little bit. Well, we can generalize the action, we can generalize these descriptions a little bit, and in doing so, we come up with a higher order equivalent. So the data input isn't an array of numbers necessarily, if we're describing it from a higher order perspective. It's an array of something. and that maps to the arguments. The action is to filter out some things, and this is where higher order functions and first order functions differ. So whereas in first order functions, the actions map directly to the body, with the higher order equivalent, we're looking at the actions being split between the body and the arguments. And so that's the key there. And then the output is an array of some things removed, and that's because when you're filtering, you're removing some things and keeping others. So I have here some key points about this. If it isn't specified in the function body, then it needs to be specified in the function's arguments. So if the function body does not contain all the behavior required to solve the problem, then that behavior needs to be sourced from elsewhere. And another point is that higher order functions input can actually be split into two. Notice how this is just called input for the first order structure, but this is called data input. That's because in higher order functions, there are two types of input. There's both data input and behavior input, and both are passed into the function in the form of arguments. So another thing to note is that the actions in all functions always act on arguments. So the difference between first order and higher order is, what are those arguments? Are they data, are they behaviors, or are they both? And so I do have another example in CoderPad. This. So like we said before, the higher order equivalent is the input is an array of some things. The action is to filter out some things, and then the return value is just an array of filtered things. So really, filtration is the primary action here, and then the tests run on the elements is the secondary action. So if we're calling the function filter, that probably means we're going to be filtering something. That's the beauty of naming functions appropriately. But what we're going to be filtering will probably change. So that's why during author time here, for the function definition, I have this function named filter. It takes two arguments, an array, and then a filtration test. Now, this filtration test is going to be a behavior that tests whether something should be included in the returned array or shouldn't be included in the returned array. So right here in the function body, I initialize a filtered array, and that's going to be ultimately my return value. And it's empty at first, but during this for loop, I'm going to be pushing values into the filtered array. But how am I going to do that? Well, as you can see, there's an if conditional here, and this is the line of importance. If filtration test, then push the current element in the array into the filtered array. So from this definition, we can see that filtration test, it will be a function because it's using invocation syntax here. We're passing the value of current into it, and we're only pushing current into the filtered array if this returns a truthy value. And if it doesn't, then we're just going to do nothing, move on to the next iteration, then return the filtered array. So the example here, how would you use this? Well, you can call filter with, so I have an array of numbers here, and it's 1 through 10, and then as you can see, this function on the next line is still an argument being passed to filter. This argument is that test for evenness that we saw earlier. And so for every element in this array, the function filter is going to pass this number, pass the element in the array into this function here, and it's going to return a true or false value. It's going to return true if the number is even, and false if it's not even. And then push it into the filtered array. And so we can see that. So it works just like the hard-coded find evens function works, except I could do this with anything. It doesn't have to be numbers. It could be characters. Say I wanted to find all uppercase characters in an array of strings. All I would do is have an array of characters here and pass in a function that would be a test for uppercase. And so that's why higher order functions provide developers with more freedom to control behaviors during invocation time. So like I said, the possible use cases for a higher order function is a lot broader than that of first order functions. And in all cases, actually, I'm not gonna, sorry about that. So the best way to prepare for all scenarios, or to account for all possible scenarios, is to not hard code them in during author time, but to allow the scenario to be specified at invocation time. So when possible, one should delegate their behaviors to invocation time if it's warranted. And so there's a test you can run kind of in your mind to determine whether a higher order function is warranted or whether behavior being delegated to invocation time is warranted. And that test is composed of 3 questions. So this is, you'd ask these in order to understand whether you should use higher order functions while you're developing a solution to a problem. So the first question you'd ask is the action you're implementing actually composed of 2 actions, a general one and a specific one? So we can hop back to get evens and ask that question. So is this action actually composed of 2 actions? Well, as we saw before, there's both a filtering out of some things, but then there's also a running of a specific test to determine whether something belongs in the filtered array. So that's 2 actions that we're seeing there. So yes to the first question. The second question is, will you need to perform the general action multiple times in your code base? So hopping back to the get evens, say if you need to perform get evens multiple times, then it still might not be the case that you should extract some of the logic to a higher order function. So every time you perform get evens, you're performing the general action of filtration and the specific action of testing whether the number belongs or not in the filtered return value. So if that's occurring in a lot of places, then that's yes to the second question. If the behavior is being used multiple times in your code base, then that's a yes. So the third question kind of determines whether or not that's meaningful is, will the specific action change case by case? So if you remember, there was an added requirement that we need to filter out odd numbers too. So that means that the general action of filtration is required more than once. However, the filtering out of odd numbers specifically, we only needed once. So we've got a general action, the filtration, that occurs more than once. And then we've got this filtration being used with different specific elementhood tests that are only occurring once. So the general action occurs more than the specific action. So that's a yes to the third question. And because the answer was yes to all 3 questions, that warranted us finding a higher order function, which was the filter function, that could run any type of membership test or filtration test, depending on the particular use case that you were encountering at that time. All right. right, so I'm just going to check the Q&A. Okay. There are actually no questions, so if anyone has any questions, they can submit them, and I'll give you a second to write. Otherwise, I'll close the session, and if anything comes up in the future, any questions about this in the future, you can ping me on Slack. And like I said, my Slack username is right there. All right. Have you used this in your own code? Yes, so the question was, have I used this in my own code? And the answer is yes. I find that there are a lot of JavaScript libraries that have built-in higher order functions. So, for example, I showed you how to implement the filter function. However, JavaScript actually has a built-in filter function that works in a very similar way. Also, when making HTTP requests in JavaScript code, there's a library called jQuery that has an AJAX method, and that allows you to submit a request to a server and then pass in another function to execute when the server responds. So that makes the AJAX method a higher order function. The next question is this like Ruby's select any and other enumerator methods? So the example my primary example of higher order functions was a function that acts on arrays. And so in that sense, yes, it's like Ruby's select any. There are some analogs between higher order functions in Ruby and, higher order functions in JavaScript and in Ruby. So functions are more analogous to procs in Ruby because procs are first-class values. However, JavaScript implements methods very differently than Ruby. Methods, you can't pass methods around in Ruby as arguments, but methods on objects in JavaScript can be passed around because they're just functions. And so the next question is similar. How are writing higher order functions different from writing methods that takes blocks in Ruby? They're very similar because in Ruby, the method body is a set of behaviors that takes supplemental behavior in the form of a block or a proc. And that's why, like I said, this isn't language specific. You see, this is a really powerful pattern that allows us to not only abstract over data, but also over behaviors. And so a lot of powerful languages implement it in their own way. And I was just using the JavaScript implementation for my examples here. All right, so that's all the questions. So, got another one that said, is this exemplified in Rack? To be honest, I don't know. I would be very surprised if the Rack code base didn't make use of higher order functions or Ruby's equivalent. I have worked with Rack before just to get a better understanding of it. I know that a lot of these types of higher level of abstraction techniques exist in Ruby frameworks. All right, so that's all the questions. If you have any others, like I said, you can ping me in Slack. Otherwise, thank you all for coming, and another thanks to Elizabeth for arranging this and putting up with my multitude of questions. All right, have a good night, everyone.